2 yesterday, right? Anybody recalls what we said? 8 into 98 goes how many times? 12 times, right? And then we said, okay, when it goes 12 times, that gives you 8 times 12, which is 96. So that's a remainder of 2 to get to 98. Everybody recall that?
Oh, yes, sir.
And then we said 8 into 12 goes 1 time, because 8 times 1 gives you 8. To get to the next multiple of 8, which is 16, you can't. So therefore you said the remainder from 8 to get to 12 is 4. And then you said 8 into 1 goes 0 times, and you carry that 1 all the way to the next remainder column. So your answer, when you convert 98 base 10 to base 8, is 142. Alright? Take this off for me. You must write this phrase. Thus, 98 base 10 is equal to 142 base 8. Alright, let me give you a moment to write off, because we did this yesterday. For those who were here, you know that we did this. So, I'm going to quickly move on now. Take a picture of it.
Sir?
Yes?
You're like for the octal to decimal, sir. And the one that you give us with the 0 in front, sir. How would you do that, sir?
Okay, that's a good question.
Would like the 0 in front of it, like the irrelevant, sir? Or would it about a place?
Alright, so let's go through that question, by the way. Alright, so he's asking, sir, you gave us a 0 point, a decimal number to convert, right? For example, 0.438. Sorry, 0.43 to base 8. And I told you that when you're going this direction, you go to a power of 1, right? But whenever you're going into the right direction, that's negative. So this first number would be -1. This second number would be -2. So 8 to the -1 is this place. 8 to the -2 is this place. When you had a positive number like 76,401, you said that each value, because they're after the decimal place, which is here, you increase from 0, 1, 2, 3, 4. But if you have the number now where the decimal is after, sorry, the decimal is before, you must say -1, -2, -3, -4. Clear?
Yes, sir.
Right. So let's look at the first column, -1. 8 to the -1, that is the same thing as saying 1 divided by 8. You put the 1 divided by 8. Okay? 8 to the -2 is saying 1 divided by 8 squared. 8 to the -3, that's saying 1 divided by 8 cubed. Okay? So once you know those values now, this is what you really have. You therefore have 4 times 8 to the -1, right? And 3 times 8 to the -2. And we're going to quickly go through how you would convert it in a moment. Alright? But let me just quickly continue here. So now we know how to convert from decimal to octal. Let's quickly convert now from octal to decimal. Alright? So what if we have 743 base 8 that we must convert to a decimal number? Look at this one, everybody. 743 base 8. I told you, now that you have each value individually in a column, you're going to multiply them and then add them together, and that value would give you your base 10. So that's why I told you this table right here you can use to convert any number to base 10. So it's not just the place value table for base 8, it's actually the conversion table to get to base 10. Alright? What do I mean? This is a very large number in base 8, correct? Right here. 76,401 base 8. At 0. Are you there?
Yes, sir.
Camera's on, everybody. Whoa, whoa, whoa. Camera's on. My camera magically turns off if yours is not on. Thank you. I appreciate it. Come on, I'm waiting on you. There we go. Emma. Okay, good. Alright. So yes, at 0, I was saying 76,401. That's a very large number, right? Are you hearing me? Can you hear me?
Oh yeah, yes, I can hear you. I didn't know I was on mute.
Right, and I told you last class, if I was converting from a small base to a larger base, the number must get smaller or larger. If I have 76,401 in a small base, if I'm converting to a larger base, would the number get larger?
No, sir, it would get smaller.
Are you sure?
Yes, sir.
Sure, you sure?
Yes, sir.
Alright, let's prove it. So that means you're saying if I multiply 7 by 8 to the 4, then add it to 6 times 8 to the 3, then add that all along, I would get a value that's less than 76,401. Let's prove it. Alright, let's check it. Let's check it. So we're going to convert 76,401. So let's do that. Converting from octal to decimal. That's the next topic. We're going to practice that one. Converting from octal to decimal using the base 8 conversion table. Alright, here we go. So we're going to say 76401 has how many numbers? 1, 2, 3, 4, 5. It's a simple trick I told you. You're going to just count the numbers and start from the least of 8 to the 0. Then you have 8 to the 1. Then you have 8 to the 2. Then you have 8 to the 3. And then you have 8 to the 4. And what you're going to do, you're going to pair these with each value. So starting from 8 to the 0 should not be paired with the 1 since that's the first number. Right? So I'm going to say 1 multiplied by 8 to the 0. Put that in a bracket.
Or should I say the answer or not yet?
Not yet, not yet. You got the answer already?
No, sir, just not yet, but like I got, 1 times 8 to the power of 0.
Right, and then the next one is going to be 0 times 8 to the power of 1. Alright, the next one is going to be 4 times 8 to the power of 2. Is everybody still following? The next one is going to be 6 times 8 to the power of 3. And the next and the final one is going to be 7 times 8 to the power of 4. So in theory now, if I add all of these together, at 0 is saying it's going to be a smaller value. And let's check and see if that's true. You want to change your answer at 0?
No, sir. I still think it's going to be a smaller number.
Alright, let's see. Alright, firstly, let's work out the first bracket. What is 8 to the 4 again? Look on the conversion table. 8 to the 4 is equal to what?
4,096.
4,096. So that means we really have 7 times 4,096. Since that is what 8 to the 4 means.
Oh no, sir.
Alright, no, you can't. No take backs. You said that you're confident.
Okay. I won't take it back.
Alright, let's go to the next one. 8 to the 3, that's 512. So therefore we're going to say 6 times 8 to the 3, which is 512. 6 times 512 plus, we're going to now go to 4. We'll say that 8 to the 2 is 64. So therefore we're going to say 4 times 64. Oops, 1 second. Here we go. 4 times 64 plus 0 times what? 8 to the 1. 8. So what is 0 times anything?
0 times anything would be 0,
So
but here it's 1.
Right, so I can just add 0 there. And then now I have 1 times 8 to the 0. What's 8 to the 0? 1. So therefore we have 1 times 1 here. 1 times 1. Alright, let's do some simplifying now. So for anybody that might not get what I'm saying, all we did, guys, is just multiply the digit that we have and the place value, and we're adding them together. So we said 7 times this, 6 times 512, 4 times 64, 0 times 8, and 1 times 1. That's all we did, right? Now let's add them together. What is 7 times 4096? Pale.
Sure, I'm looking it up now.
Alright.
Sir, 7 times 4096 is 28,672.
Alright, that's a very large number. We're gonna add that now to what is 6 times 512?
Sir, I said 28,000.
28,000, my bad. Right, and then now we're gonna add that to 6 times 512. What's 6 times 512?
300.
3,000? Okay, Google. What's 6 times 512?
3,072.
3,072, good. Plus, what is 4 times 64?
256.
256 plus 0, 0 comes back, plus 1 times 1, which is just 1. Alright, now let's add them together. What's 28,672 plus 3,072?
Sir, were we supposed to add them in base 8 or regular?
32,000.
So 38. Once again, your question is, are we gonna add them? You said.
Are we gonna add them in base 8 or?
So before we add them in base 8, we expanded them first. So we didn't add this column. We added what is this number times the digit, right? Because that is dependent on what number it gave us. If it didn't give us 76,401 and another value, like for example 58, you know we only use these two columns, 5 here and 8 here. So it's dependent on the value itself. So he said now 28,672 plus 3,072 gives you
32,003.
33,003.
Or 32,003.
32,003. Good. Plus, so we just added these two values, right? Just added these two values. It's a very large number so far. What is 256 plus 1? 257, am I right?
Yes, sir.
Alright, so that was the associative law. We grouped the numbers and added them together. Good. So what is 32,003 plus 257?
Sir?
Yes?
Sir, the 32,003 was everything added together, sir.
Oh, okay. Alright, so I told you Jesse was a genius. Okay, good. So this answer is in base 10. So therefore your final answer is going to be thus 76,401 in base 8 is converted to 32,003 in base 10. Obviously you're going to put the letter 8 below it. Alright, any questions?
I was correct.
Can you repeat that for me?
So then I was correct.
Oh yes, you were actually. You were correct. You were actually correct. My bad. All right. So that's a little trick about it. You need to be confident because I kept asking you, and you just kept saying yes. So that showed me that yes, you know you're correct. Because the rule I gave you yesterday, what did I say? If you're converting from a smaller base to a larger base, the number must be smaller. All right. But however, if I have a large base and I'm converting to a smaller base now, the number will be larger. So if I'm going from base 10 to base 8, the number will look larger. Clear? But let's see some little examples now, because this was very difficult. Let's use a little smaller example for those who might not get it as yet. Alright?
So decimal this time.
Okay, you said decimal? Sure. So we're going to convert 0.74. Alright? Let's do that one. We're going to converting 0.74 base 8 to base 10 or decimal. Here we go. Now, who had an issue with this question? Let me see who was pulling their hair out trying to find this question. You guys all found it easy?
No, sir.
Alright. So that's not bad. Alright. So remember the rule I told you. If we're going in the left direction, when we're having positive numbers, 76,401, all of those were positive numbers, right? So they had a power of positive values. But if now I have a decimal that's going in the opposite direction, it's no longer going to be 8 to the 1, but rather 8 to the negative, because it's going in the opposite direction. The decimal place is not going here, rather it's going in the right direction. Okay? So the first power of 8 now is not going to be 1, but negative 1. The second power of 8 is going to be negative 2. So if I have now 0.74, the 0.7 would be 8 to the negative 1. And what would be the 4 now, Jazeel?
Wait, sir, can I be excused for a minute?
Alright, sure.
Pastor, can you repeat?
Alright, let me go over it again.
The negative 2.
8 to the negative 2. Follow with me now. Let's use this example, Kai. If I have 0.43, right? Because I don't have a big number, I have a decimal instead. The powers are going to be in the opposite, which is going to be negative signs. So I'm not going to have 8 to the 1, I have 8 to the negative 1. So the 4 would be the first negative number, so that's 8 to the negative 1. Right? So we're going to say the 4 goes under that column. The 3 is the second one. So we're going to say 8 to the negative 2. So this is how you would write the numbers now. And what the rule did I say? When you're trying to find it in base 10, don't you just multiply the digit by the power? Right? So what you're going to do, when you have 0.74, you're going to multiply 7 by 8 to the negative 1 plus 4 by 8 to the negative 2. Any questions?
1? Wait, 4.
But remember what I told you. I told you that last week. When you say 8 to the negative 2, I said picture the negative sign as a division bar, then place back the 2 in the power. So if I remove the negative from that division, from that power, what do I have left? Isn't it 8 to the 2? Hello?
Good, sir.
I need to hear from some persons. I don't know why I'm not seeing everybody. No Kiman, no Khalil. Alright, I'll check up on him after. Camera on for me at 0. Right? If I have 8 to the negative 1, I told you, picture the negative as a division bar. Right? And then place back the power in front, and then put it as a denominator. So let's write that down. The steps to writing a negative index. For example, 8 to the negative 2. Step 1, picture the negative sign as a division bar. For example, divided by, okay, 1 divided by 1, for example. Okay, then the next step is going to be place back the number in the power as the power of the base. So we're gonna have 8 to the 2 now. And then the final step, express as a denominator over 1. So 1 divided by 8 to the 2 is the same thing as 8 to the negative 2. What is 8 to the 2 again? 8 to the 16, right?
No, 64.
Okay. So we're gonna have 1 divided by 64 is equal to 8 to the negative 2. And we can go even further. We can say, what is the decimal of 1 divided by 64? You're gonna just simply say, how many times can 64 go into 1? Alright, so quickly write off these steps for me. The steps to writing a negative index. Any questions? Harry?
No, sir.
Alright. Cassania, any questions?
No, sir.
Alright. So, let's look at this example now. We have 8 to the negative 1. What do we say that number is going to be equal to, Cassania? If we have 8 to the negative 1, what can you picture it as? Follow the 3 steps. So, what is 8 to the negative 1? That goes to Cassania.
Not sure.
What is 8 to the negative 1? What is the first step I told you? The first step was to picture the negative as a division bar, right?
Yes, sir.
There we go. And what's the next step?
Divided?
Right, but I told you to put the number 1 as what? A power of 8, correct? So what would you have? 8 to the 1. And what did I say you should do with that 8 to the 1? Where should you put it? In the numerator or the denominator?
Numerator?
The numerator, you said?
Yes.
It's gonna be in the denominator. And then I say you just put a 1 above it. Clear?
Yes, sir.
Okay, let's try another one. This is gonna be all you. We have 8 to the negative 3. What's the first step? Picture the negative as a... Can you repeat that for me?
I forgot the step.
Picture the negative as a division bar. Come on, picture the negative as a division bar. And what's the next step? What are you gonna do with the 3? Where are you gonna put it?
The denominator.
Right, you're gonna put the 8 to the 3 in the denominator and imagine that you have a 1 above. So the answer is therefore gonna be 1 divided by 8 to the 3. And then you can find what 8 to the 3 is, which we know is gonna be 512. So therefore that is gonna be 1 divided by 512. Alright, I wanna make sure you understand. So don't just say yes sir. You actually understand what I just did?
Yes, I actually did.
Great. Alright, so when we have that fraction that we just got, 8 to the negative 1 is the same thing as 1 divided by 8. 8 to the negative 2 is the same thing as 1 divided by 64. Good? And then now, all you're going to do is fractions. You guys know fractions. You're just going to multiply 7 times 1 divided by 8. What does that give you, Pale? What fraction do you have as a result? 7 times 1 divided by 8.
7 over 8.
7 over 8. And then you can express 7 over 8 as a fraction, which is 0.875. Clear? Alright, next one. What is 4 times 1 over 64? Pale?
4 over 64.
But that can be simplified, correct?
Yes, sir.
How many times? So how many times is 4 going to 64?
16.
Repeat that for me.
16.
16. So therefore, 4 divided by 64
Equals 1 over 16.
right, can be simplified as 1 over 16, or we say it is an equivalent fraction. Right? They represent the same value. And 1 over 16 is equal to 0.06 as a decimal. Clear? 0.0625 as a decimal. 0.0625. So once we've done that now, we're gonna just add those two numbers together, and when we add them together, you must get a decimal number which is a bit larger. Alright, so we got 0.74 as our base 8, therefore our answer must be 0.9375 in base 10, and you typically round it to 2 decimal places. Clear, everybody?
Yes, sir.
Alright, now it's 9:30, right? But I want to give you one question to practice, and you're gonna submit your homework if you haven't done so. But for the person who has submit, I am paying attention, don't worry, and you're gonna get commended for it. Good job for that person. Okay, so here's your question. Convert 0.214 base 8 to base 10. So you're gonna practice the decimal number now. 0.214, convert 0.214, convert 0.214 base 8 to base 10. Explain the steps in number. Explain the steps as you go along. Yeah, just that quick homework. Since a lot of you guys didn't finish the homework on the portal, just add this to your homework when you submit it later today. Alright? Have a great day, everybody. Any questions, please let me know. You guys are going to get a revision test on everything next class, which is just basically learning how to, or remembering how to add and subtract, right, in bases. Even though we didn't go through add and subtract in base 8, we went through adding and subtracting in base 2 and base 5. So it's the same idea.